So we're going to talk about mirrors today. We're going to start off with a concave mirror. Alright, so we draw the concave mirror, and then we're going to draw our baseline using our straight edge. Now, I didn't mean to make an ASMR video, but it just turned out that way. Okay, everyone's asleep. Now we put our focal point at some point. We put our object at another point. It's going to be a pencil, very well drawn, might I add. Then, to do this drawing, we need to start drawing our various lines. We'll start with line number 1, which goes parallel to the baseline. Now, we draw our line parallel to the baseline. We break our lead, and we keep going. Now this particular line reflects through the focal point. This is R1. Here in a moment we will label those 1 and R1. Now the next set of lines starts at the top of the pencil and goes through the focal point. So we draw that line using our straight edge, which is totally not a fan, and then that point, or that particular ray, reflects parallel to the baseline. Those ones are labeled 2 and R2. Now our image will reside where R1 and R2 meet. That part of the image will be the part where the light came from. Well, the light came from the top of the pencil, so that is the part that we will draw. There's our image. Now, to do the breaking off a little lead again. To do the mathematical portion for this particular setup, we are going to need some pieces. The equation we have is 1 over P plus 1 over Q equals 1 over F. In this particular case, we're just going to kind of eyeball it, and we're going to define these letters as we see fit. So why don't we go ahead and just say P is about I don't know, maybe 10 centimeters, sure. And we'll say that F is, a little less than half, so probably about 4 centimeters. And then Q, we do not know. So we are going to try to find Q. Now, all we got to do is we got to plug in our numbers into our equation. P is 10, Q we don't know, and then F is 4. Now next, we are going to solve the equation. We could do it with either decimals, or we could do it with least common denominator. In this case, I break my lead. In this case, we will do just least common denominator, because these numbers aren't too bad. Okay. So 1 over Q equals 1/4 minus 1/10. Now we deliberate. We say, what do we need to do to make these two reach the exact same number? Well, for a fourth, what we need to multiply is by 5 over 5, drawn in a very strange way. And then for 1/10, we need to multiply 2 over 2, because those two will meet at 20. So 5/20 minus 2/20. Now, hopefully you can do that inside of your brain. 1 over Q equals 3 over 20. Now to finish our problem, all we have to do is we need to take the reciprocal of our number. So Q over 1 equals 20 over 3. Of course, another way of writing that would be, inside of your brains, you can do the calculation there, that this Q should equal me 6.6 repeating centimeters. Now the next thing we got to do is we got to take this number and we got to put it into our magnification equation. So we do negative Q over P for the magnification equation. Magnification. So it's going to be negative 6.666666666 repeating over 10. Now once again, we could do this on a calculator, but the astute observer will remember that you just move your decimal over one place. Ugh. Originally I said it's similar to, but you know what, it's going to be negative 0.6 repeating. Now, the magnification, if it is negative, so if m is equal to a negative number, then we know that it is both a real image and that it is inverted. Now we're going to look at our drawing and verify that that is true. We go up to our drawing here and we see that it is upside down and it is on the correct side of the mirror. Okay, over here we have the real side and over here we have the virtual. In this particular case, we are on the real side.